Okay. And we are back. Okay, so we did the best we can with that section. If I need to redo the video, I will. So let's continue. So this next section is 5.5. Now, I want to introduce this shortcut. So now we've seen, the trig functions of, 30, the 45, and 60, and all of that. So now, let's see. So I'm just going to kind of give it to you, actually. So the objectives, we want to find the exact values of trig functions using the unit circle. Know the domain and range of trig functions. Use the periodic properties to find exact values of trig functions. And use the even and odd properties. Okay. I would like to start off with my own slide. So what I want to do is get rid of this. And I want to do a new slide right here. How do I insert? Okay, I just want to show you the unit circle. Okay, so now, I'm trying to think. I'm going to start with the shortcut. So to do this shortcut, we're going to start by focusing on Quadrant One. If you can master Quadrant One, you actually master the whole unit circle. Okay, so here's Quadrant One. All right, here's the positive x. Here's the positive y. We're going to consider a circle of radius 1. So then that means here at the top, we're at what? 0, 1. And then a circle of radius 1. So then something like this. Is that okay? So over here, we're at 1, 0. Right? This is 45 degrees. This is 60 degrees. This is 30 degrees. Something like that. So then, again, this is 30 degrees. This is 45 degrees, and this is 60 degrees. So 30 is this one. 45 is this one. 60 is this one. Okay, so let's go ahead and do all the ordered pairs. So here's a blank set of ordered pairs, blank set of ordered pairs, and a blank set of ordered pairs. All the denominators are 2 for this, so we're just going to do 2, 2, 2, 2, 2, 2. Now, here it is. How well can you count? Are you good at counting? Can you count 1, 2, 3? Then you've actually mastered it. 1, 2, 3, 1, 2, 3, and all the numerators, we take the square root of all the numerators. Now, what does this, didn't need that last one. What does this mean? Right? So what we're saying, now, we said before that cosine is our what? X or our Y? So these are all cosine of theta, and the y's are all our sine of theta, right? Again, this is a unit circle, right? So if you can count 1, 2, 3, 1, 2, 3, all that stuff that we did before is right on the board right now. For instance, if we were to say, what is the sine of 30 degrees? You see how it works? What is the cosine of 45 degrees? Cosine of 45 degrees. You see it? See how quick that is? What is the sine of 90 degrees? 90. 90. Okay, so the thing I didn't write. Yeah, right? So 90 degrees is up here. So this is 90 degrees up here. This is 0 degrees down here. So if we say sine of 90, is sine our x or our y? So what's sine of 90 degrees? 1. Is that okay? Because it's at the top. What's cosine of 0 degrees? Cosine of 0 degrees. 1, right? Because cosine is our x. 0 degrees, we're at the bottom. So then that's 1. Does this make sense?
So it's further kind of
The angles are here. I think you're overthinking it. Okay, for instance, well, these are the main angles that pop up that we're going to be discussing a lot, right? Haha. I'll message her later. Let's try again. Tell me cosine of 30 degrees. So if we're doing 30 degrees, which one are we considering? The one that says what? 30, right? What's cosine of 30 degrees? Root 3 over 2. What is cosine of 60 degrees? Okay. What's cosine of 0 degrees? 1. Okay. What's cosine of 90 degrees? 0. Just zeros, right? It's in the upper left. What is sine of 45? You see how you use it now? So, I mean, the construction is really easy. When you're at the top is 0, 1. The right is 1, 0. All the denominators in the middle are 2. You just count 1, 2, 3, 1, 2, 3. And then that's so when you see me counting in my head, this is the chart that I'm visualizing. This is how I remember all those numbers. I'm just counting 1, 2, 3, 1, 2, 3, and then I go from there. All right, so let's see this in action. If I could get a copy of this, this actually would be great. Now, this is quadrant 1. So whenever we are 30 degrees away from the x-axis, the cosine is root 3 over 2. The sine is a half. Whenever we're 45 degrees away from the x-axis, the cosine is root 2 over 2. The sine is root 2 over 2, so on and so on. Okay, let's see this in action. I'm going to leave this at where it is for now. Okay, let me think about this. Do I want to go through these details? So what's going on with the unit circle? We consider a circle of radius 1, and we draw a line that's tangent to the circle passing through the point 1, 0. Now, when we wrap this tangent line around the circle in a counterclockwise direction, that's the positive. So the positive x-axis on this circle, on this tangent line, wraps counterclockwise. The negative direction on this line wraps clockwise. So then what's happening here, all of these points on this tangent line correspond to some ordered pair on the unit circle, right? So when we say sine of t, that t being some point on that tangent line, is going to correspond to some ordered pair on the unit circle. So that's the backstory behind what's going on here. To me, that's a little bit overcomplication. Now, we're asked to find sine of t, cosine of t, so on and so on, right? Given this ordered pair. So this ordered pair, if we were to plot it on I think it's the unit circle. So if this is a point on the unit circle, we can still do the whole x squared Pythagorean theorem. X squared plus y squared equals r squared, right? So it should be the case, let me think about this. That squared plus that squared equals 1. How do I usually do this? I mean, honestly, this one we could just use right triangle trigonometry. We're not even using the unit circle just yet. So we can kind of do something like this. If we go negative and then negative, so we could be somewhere like this, right? Where this will be our theta. This is the negative root 3 over 2. This is a negative 1/2. This should be 1 because we're on a unit circle. Okay? So then given something like this, so then when we go to find sine of t, what's the sine if we're using this? Or long story short, we don't even have to do all this. We're on the unit circle. The sine is at our x or is that our y? That's our y. What's our y value here? So this result should just be our negative 1/2. Tell me about cosine of t. Is that our x or our y? So that should be what? Okay. Sine, cosine, tan of t. So tan is what again? What over what? So then this result should be what? Okay, keep going. Over the negative 3 over 2, root 3 over 2. So then the final result is 1 over root 3, which becomes root 3 over 3. Okay. What's the reciprocal of sine is what? Cosecant. So if we flip it, we get what? Negative 2. Reciprocal is cosine is secant. Almost. Negative 2 root 3 over 3. Okay, that's okay. And then cotan of t is just root 3. All right? I think those are results. I'm going to let that be for right now. What's the time? I think we're about out of, we got a good amount. We got a few minutes. Let me duplicate this. Let's go ahead and, duplicate this one. Duplicate this one. I'm going to get rid of the text. Let's get rid of this as well. And then this one I need to get rid of my annotations. Okay, and I think we're back in business. 29. Actually, we might be able to finish this one because it's not as long as the others. So we did this one again. So here we're using that cosine as our x and sine as our y. So we didn't have to do all the other stuff. Also, because we're on a unit circle is why we can do this. Okay, with this ease. Okay, so we're going to let that be. I think we got all these results. I think these are okay. We're going to let that be. So we kind of notice that sine of the angle, sine of theta is the same as sine of theta. So this is pretty straightforward. This is kind of intuitive. Now, if we're on a circle where the radius is not 1, instead of sine being our y and cosine being our x, you got to do x over r, which is the radius. So to factor in that radius, you have to divide by r. So now, to be a little bit more precise, cosine is x over r and sine is y over r. It's just that when we're on a unit circle, the radius is 1, right? So if the radius is not 1, we have to divide by that radius. Okay, let's see this in action. So we talked about this. So this is kind of recapping like the 45, 45, 90 and the 30, 60, 90. But again, all of these results, the results for this and the results of this are on the unit circle where we say the 1, 2, 3, 1, 2, 3. That's what this is referring to. Okay, so it says if we're considering the point negative 3, 4 is a point on the terminal side. So we need to find the radius, right? So we can use the following. I know it's a little bit back and forth. You just have to do the best you can. So we can use the following. X squared plus y squared equals r squared. If we were to plot those points, we got to find the radius. So same kind of deal there. Okay, let's just plug in what we have. Where'd it go? Let me just clear the ink. And actually, I think I need to duplicate this slide. Let's get rid of all of this. Okay, let's see it in action from the current slide. Okay. So now, again, we're going to use the formula x squared plus y squared equals r squared. Okay, our x in this case is the negative 3. So that's going to be 9 plus 16 equals r squared. So then the radius is going to be what? 5. Is that okay? Is that okay for the radius?
Yes.
Okay, so now that we have our r, we're ready to find all the trig functions. So when we go to do sine of theta, is sine our x or our y? So for discussions going forward, we need to do sine is y over r, right? So then, so that one should be 4 over 5. Tell me about cosine of theta. So it's going to be x over r. X is negative 3 over 5. So now that we have sine and cosine, the rest just naturally flow. Tan is what again?
Sine over cosine.
So then what's that result going to be? So if we did sine over cosine, that's going to be a negative 4 over 3.
Oh, really? Oh, yeah.
Okay.
Yeah.
So reciprocal of sine is what? Cosecant. That's okay. So if we flip it, reciprocal of cosine is secant. That's why I try to get you to repeat it. So because like once you hear the rhythm, it'll register. Secant. Say it, repeat after me. Secant. 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 Tangent. Tangent. Forget about the co for right now. Secant. Tangent. Sine. Secant. Tangent. Sine. Once you master those, it's easy to put co in front of it, right? Okay, that's okay. Secant. So what's the reciprocal? What's the result? But I mean, I get that you know what you're talking about, so it's like I'm not too worried about it. But it helps when you can articulate it properly. What's this result going to be? Does that work? No? Okay. -5/3. Okay. And then what? Cotan. Any questions here? Do we agree or disagree? Do we need to... Let's see, how do we do? Did we get... We got all these results? I think we're missing a negative, so cosine. Let's go back. No, I think we're okay. Yeah, we're okay. All right. What's the time? We got like a solid 10 minutes, right at 10 minutes. I think I can wrap this up. The domain and range of trig functions. I'm going to kind of skip that for right now. To me, the domain and range of the trig functions are easier once we look at the graphs of these trig functions. Because once you see the graph, then to me, that's easy. That's a better, I would rather talk about domain and range then. I'm going to let that be for right now. I'm going to come back to this. I'm going to let that be, let that be. I'm going to let that be. Okay. How many more slides? We got 4 more. So we're going to be able to wrap this up. Okay. So now, we're asked to find the exact value of each of the following, 765, right? So we have to remove what? Our complete revolutions. How many times did we do a revolution? 72, right? 2 full revolutions. So let's do this. Hey Siri, what's 765 minus 2 times 360?
765 minus 2 times 360 is 45.
So part A is really the same as sine of 45 degrees. So now, let's revisit that shortcut that we introduced from the unit circle. This is my favorite way to do it. So I'm gonna do a quick sketch of the unit circle here, right? All the denominators are what again?
2.
I'm a little jammed here. Let me see if I can just load an image. Let me just get a copy of what I've already drawn so I don't have to draw it again. We're going to get a copy of this one. So I'm going to go like this. Is everybody comfortable with the construction of this? Do I need to construct it again? Do I need to construct it again? Okay. So I'm not going to construct it again then. I'm just going to take a copy of this and use it. I just want this. I'm going to hit done, and I'll save it to photos. That's fine. So now I'm not really sure where we left off. We were down to like 20-something. We were like, yeah, this is where we left off from that slide. And then honestly, we need to, can we paste? Okay, let's go to this one. That's fine, I don't have nothing like that. So this is the one we just used. Okay, so I'm gonna make that like this so we can have that for a reference. I actually need to duplicate this slide and move this here, and I need to get rid of this stuff. All right. And let me actually insert it here. Can I just like cut, paste? So I'll keep it, I want to keep it in the upper right hand corner here for a reference. Hopefully that's not too small. Let's go here. And we'll just do the best we can with the space. I'm going to delete this slide. Okay. So back here. Okay. So now, Now we have a copy of our 1, 2, 3. Everybody see the 1, 2, 3, 1, 2, 3? Okay. So now from here, what is sine of 45 degrees? It's root 2 over 2. So then that answer is simply, this one is just root 2 over 2. Okay? That's it. That's why I was like, that chart, once you master it. And so whenever we're 30 degrees away from the x-axis, there's the cosine, there's the sine. No matter where we are on a circle. Whenever we're 30 degrees away from the x-axis, there's the cosine, there's the sine. Whenever we're 60 degrees, there's the cosine, there's the sine. The only thing the quadrant tells us is whether it's positive or negative. That's what we have to straighten out if we go to like quadrant 2, 3, or 4. It's the exact same thing. It's just like a mirror image, right? We had to straighten out whether it's positive or negative. Let me kind of wrap this up because we're almost out of time. Okay. So the next one, 25 pi over 4. Now there's a shortcut for that to leave it in radians without having to convert. For me, the simple thing right now is to just convert to degrees. But I have a shortcut for leaving it in radians without converting. But I'm not going to do that just yet because I can't articulate that one as well as I can this one. So I'm going to convert to degrees. 25 pi over 4, 180 over pi. These are gone. 45 times 25, whatever that is.
45 times 25?
Yeah, if we have 45 quarters, 1125. So is that one the same as tan of 1125? Is that right, for real?
Yes, it's 11.
You know how I did that so quick? Because we said 45 times 25. So that's like having 45 quarters. If we have 45 quarters, right, how much money is that? Well, 4 quarters is $1. So when we get to 44, how many dollars is that? 44 divided by 4 is 11. So that was $11, and you had 25 cents left over. So that's where I got the 11.25 from. Well, money, it's just money. Like, think about it in terms of quarters. When you think of quarters and money, every 4 is $1. So like if you had, I don't know, 9 quarters, how much money is that? What's 225, right? So 9 times 25 is 225. If you think in terms of money, it becomes manageable. You can do it. You can do it. We're gonna let that be. We're gonna let it be. Let's because we're almost done. Let's just try to wrap it up. So now 1125. We need to pull out the complete revolutions. How many complete revolutions did we do? 2. Is it more than 2? 360. Let's do this. Hey, is it 3 full revolutions? Hey Siri, what's 1125 minus 3 times 360?
25 minus 3 times 360
Sorry.
is negative 1,055.
1125. Let's try it again. Hey Siri, what's 1125 minus 3 times 360?
45.
1,125 minus 3 times 360 is 45.
Yeah.
So again, we're in quadrant 1. So now, if we're doing tan of 45, tan is what over what again? So then if we did sine over cosine of 45, sine of 45 over cosine of 45, what is that? 1, right? You see how the chart is nice? Yeah, once you get it, everything, and so in my mind, I just go 1, 2, 3, 1, 2, 3, and I can see it. And it's not difficult once you see it. So this is just 1, okay? So I think that's that answer. And let's just go ahead, that was part B, and let's go ahead and do C. I'll do it here for the space. 11 pi over 3, I'm just going to convert that again for the sake of time. There is a shortcut, so if you can find it, that'll help.
So my question would
Hang tight, write it down, because I'm trying to get you all out of here. 6, it's 60, 66, so 660. Okay, so if we're at 660, so we're really doing cosine of 660. Let's see. Hey Siri, what's 660 minus 360?
660 minus 360 is 300.
So if we're at 300 degrees, what quadrant are we in?
Third one.
Fourth one, right? 0, 90, 180, 270. So we're in quadrant 4. So what's the reference angle? How far away from the x-axis? 60 degrees, right? So this is actually the same as cosine of 60 degrees, again, in quadrant 4. Okay? So from the unit circle, what's the cosine of 60? What's the cosine of 60? One half, right? If we're in quadrant 4, is our x positive or negative? So then our result should be positive. Let's see how do we do. We can use our calculator to check. I'm just trying to get you all out of here. We got root 2 over 2. We got 1 and then a half. And I need to get rid of that. Keep this. Yes, delete. Current slide. I'm watching the clock. I'm getting you all out of here. We got that one. We got that one. We got cosine is our x. Are we not in quadrant 4? Wait a minute. We got to back up. So 660. Did I do that conversion right? 180, 666, 660, 300. That should be quadrant 4. X is positive. Why is that not negative? Maybe that's a typo. Okay, let me do this in the calculator really quickly. 11 pi over 3. Hit cancel. I'm going to go refresh, reload, and refresh. We said 11 pi over 3. Cosine is our x, yeah. So let's hit mode. We're in radians. We're going to hit cosine of 11 pi over 3. Yeah, I'm going to say that's a typo. I'm gonna stand by that being a typo. So I think that's supposed to be positive. 3 pi. Yeah, if somebody can figure out if that's a typo or not, I think that's a typo though. Okay, so I'm gonna let that one be. I can't see why that's not a typo. Let me see if I can do anything. Again, the even and odd properties, to me, these are easier if we look at the graph. But basically, a quick way to remember this is that all the trig functions are odd except for the ones associated with cosine. Cosine is even. So by definition, what I mean by that, then we'll get out of here. So odd, what does odd mean? Anybody know that one? What does odd mean? So a function being odd means that it's symmetric with respect to the origin. So the definition means that whenever we do f of negative x, this is the same as negative f of x. It's like we can factor out the negative. A function being even means when we do f of negative x, it's like the negative is gone. So we finish with f of x. This means origin symmetry. Origin symmetry. This means y-axis symmetry. When it's odd, you can essentially factor out the negative and pull it in front. When it's even, the negative disappears. That's what I'm going to say on that one. Let me see. Is this the last one? Okay. So this is it, and then I'll let you go. I see the time. I know we're a little bit over. 30 degrees. From the unit circle, anybody got that? 30, 1, 2, 3, 1. So that should be a half, right? Since sine is odd, this is the same as negative sine of 30 degrees. We just said that sine of 30, 1, 2, 3, 1 is a half. So that result should be a negative 1/2. This might be the reason why the other one was negative 2. It might be something here. So I had to go back and look at that one. I'm going to go with this for right now. And we'll check it in a moment. Now pi over 3, I'm not gonna do the radians just yet. 180 over pi, 60 degrees. So this is the same as cosine of negative 60 degrees. Cosine is even, so this is actually the same as cosine of 60 degrees. 60, 1, 2, 3, cosine is our x, so that's a half, right? Keep me honest. Don't let me just give you. 5 pi over 4, it should be a 45 cotan. Okay, I'm going to do the conversion. 180 over pi, 45 times 5, 90, 180, 225. So this should be the same as cotan, that's a t, cotan of a negative 225 degrees. Cotan is odd, So this should be the same as negative cotan of 225 degrees. 225 is quadrant. Let me see if we're going. That's fine. 1, 2, 3, quadrant 3. So that should be positive. It's 45, so that should be a negative 1. I think that's the result there. We're going to check it in just a moment. That's another 45. That's odd. So this should be the same. I'm just going to kind of jump. Tan of 29 pi over 4. That's a 45. Let me just make sure. 180 over pi, 45. Hey Siri, what's 45 times 29? Hey Siri, what's 45 times 29?
45 times 29 is 1,305.
1305. Let's do 3. Hey Siri, what's 1305 times... Hang on it. Hang on. Hey Siri, what's 1305 minus 3 times 360?
1,305 minus 3 times 360 is 225.
Let's see. So then 1, 2, 3. That's fine. Quadrant 3 is positive. That's a 1. I think this was also negative 1. I'm going to let that be for now. I'm going to look at the results. We got a negative half, half, negative 1, negative 1. Let's see how do we do. Negative half, half, negative 1, negative 1. Okay, I know that was a little fast because I'm just trying to get you all out of here. If you have questions, you can stay after and ask. Otherwise, have a good weekend. So take this homework home, this worksheet home. Bring it in at the start of class on Tuesday for credit, okay? All right, so take a look at the homework. If it's not making sense out of the book, it's definitely a good idea to log into Pearson and work on the Pearson. That's why I make that available, because it's an alternative explanation for every question. Okay? Have a good weekend, lovely people. I'll see you Tuesday.